Hi, this is the Check Your Understanding on page 397. To introduce her class to binomial distributions, Mrs. Desai gives a 10-item multiple choice quiz. The catch is students must simply guess an answer, A through E, for each question. Mrs. Desai uses her computer's random number generator to produce the answer key so that each possible answer has an equal chance of being chosen or to be chosen. Patty is one of the students in the class. Let X equal the number of Patty's correct guesses. So the first question is, show that X is a binomial random variable, and this is where we check 4 things, and the acronym for them is BINS. So the B stands for binary, and yes, this is met because a success, we're checking to see if there's just a yes or no or success or failure, and a success is answering correctly, and a failure is just answering incorrectly. Independent is also met. The answer to each question was produced randomly, so the answer to each question each question is independent from one another. If you know the answer to one question, that's not going to affect knowing the answer to another question. Number means, is there a fixed number of trials? And yes, there is. It's 10. It's 10 questions. And then S is for same probability, and yes, the probability of answering a question correctly is the same each time. It's always going to be 0.2 or 1/5 because the answer choices were A through E. There's 5 choices and only one of them can be correct. So number 2 is we want to find P of X equals 3, which means the probability that she gets exactly 3 correct. So let's go back to the numbers that we need for the equation for solving this. N is the number of trials, and it's 10. P is the probability of a success, and it's 0.2. And then X is 3, and that just means we're looking for 3 successes out of the 10. So our equations on the formula sheet, we would do 10. This means 10 total, 10 is the n, 10 is the total number of trials, and we want 3 out of the 10 successes. These are the combinations, all the ways to get 3 objects out of 10 total. And then the 0.2 is the probability of a success. We want 3 of those. And then 0.8 is that she gets the question wrong, and we want 7 questions incorrect. What we can do is just go to the calculator, and we go to distribution. So I'm going to type second, distribution, and we're looking for binom PDF. PDF. We want the PDF one because we're just looking for exactly, like an exact number. We want exactly 3 correct. Press enter. Total number of trials is 10. Probability 0.2, and then we want 3 questions correct, 3 successes. So we get about 0.201. About 0.2. So that means there's about a 20% chance that Patty gets exactly 3 questions correct on this quiz. And then number 3, to get a passing score on the quiz, a student must guess correctly at least 6 times. Would you be surprised if Patty earned a passing score? So we need to calculate the probability that she gets at least 6 questions correct just by guessing. Again, n is 10, the probability is 0.2, we're still using the same numbers. X is not 3, actually, sorry. We want to use that it's at least 6, so this, we're looking at 6. 6 or more, so that means if we do just 6, this is what it would look like. So 10 is the total, we want 6 out of the 10, all the ways to get 6 out of 10 correct. And then 0.2 is the probability of getting a question correct. We want that to happen 6 times. And then 0.8 is the probability that she gets it wrong, and we want that to happen 4 times. Or she gets 7. So this is for 6 correct, or you would do 7 correct, or 8 correct, or 9 correct, all the way to 10 correct, which would be this one. She gets all 10 correct and none of them incorrect. So we could just do each of those separately and go to the calculator, go to binom PDF, and just calculate each one separately, add them up. Another way to do it is to use binom CDF. CDF, though, only gives you less than that value. So if we put in 6 in a CDF, it's going to give us 1 or 2 or 3 or 4 or 5 or 6 correct. But we don't want that. We want 6 or more. So what we're going to do is use the complement. The complement of 6 or more is less than 6 or 5 or less. So what we can do is go to second distribution and go to binom CDF. Again, 10 questions, and 0.2 is the probability of getting a question correct. And we're going to put 5 because we want to do the complement. So this will give us either 0 or 1 or 2 or 3 or 4 or 5 questions correct. And since we want 6 or more, we're going to do 1 minus that answer. Whoops. One minus that answer. So just the 5 or less was about a 99% chance, and then 6 or more is the complement of that. 6 or more correct is about a 0.6% chance.